This is chapter 4, lesson 6, negative and zero exponents. So we were dealing with exponents the other day, and now we're going to be dealing with negative ones. And so this is a really important rule to understand. For negative and zero exponents, for any non-zero number x, x to the 0 power is equal to 1. It does not matter. It could be 2, could be 5, could be 7. Any of these are actually equal to 1. It does not matter what the number is, as long as it's not 0. And for any non-zero number x and any integer n, that means to the n power here, or to the negative n power, then it's equal to you put the 1 in the numerator, and then underneath you put x to the nth power. So let's look and see what this actually means. So for this one here, 5 to the second power, that is going to be 1 because it's a negative power, 5 to the second power. For this one here, this is just a number to the 0 power, so it's just going to be, it's not going to be 0 anymore, even though it's 1, 0, 0, 0, 0, 0, 0. That's a lot of zeros, but it's to the 0 power. So all that crosses out, and it's equal to 1. For this one right here, it's going to be 3 on top, and then y to the second power on the bottom. Because the 3 on top is sort of like the coefficient here. If we had 3, for the example here, 3 times x to the negative n power, then it would be 3 over x to the nth power. So now for this one here, it's going to be, well, we can just add together these because, well, actually we can't add together these, x and y, different things here. So it's going to be y to the third power, so that's positive, over x to the seventh power. For a second I thought those were both x's. For this one here, it's just going to be 1 over 7 to the first power. We don't even need to list that. For this one here, it's just going to be 1. Now for this one here, let's clear this off. For this one here, now we have to make sure that x is a non-zero number, so we have to kind of list x is not equal to 0. If that's the case, then this is going to be 6 times 1, that's what the x to the 0 power is, divided by y to the second power, because that's that part right there. So it's just going to be 6 divided by y to the second power. This one here, well, we got a negatives and negatives, so it's just going to be 1 over x to the 11th power times y to the first power, or we could just say x to the 11th power and y under 1. So write the you can go ahead and write this expression using the fraction power. If you have here 1 over 27, that's the same as, now if you remember, 3 to the third power is equal to 27. But you're no longer doing it 3 to the third power. 3 to the third power is on the bottom. So you could go ahead and do the prime factorization for this, and you would realize that it's 3 to the third power is on the bottom there. And then what you do is you can just change it into a negative 3, because 3 to the third power over this, that's the same as that. So for example here, x to the 8th power divided by y to the 17th power is the same as that expression, x to the 8th power times y to the negative 17th power. So it's just, we're moving that and we're changing the exponent part to the negative, and then we're just changing it to multiplication. So in this case here, we know that 64 is 8 to the second power. So this is going to be 1 over 8 to the second power. So that's going to be equivalent of 8 to the negative second power. For here we know 100 is 10 to the second power. So it's going to be So that's going to be 10 to the negative second power. So now for this one here, this says, just rewrote it over here. So this is the same as x to the fifth power times y to the negative second power. For this one here, this is both x to the fourth over y to the fourth, so it's just going to be x to the fourth times y to the negative fourth. So it says here, find the product or quotient. Write your answer using only positive exponents. So the tricky part here will you can only use positive ones, so you've got to have it be a fraction if you have a negative exponent in there. So let's look and see what this is. So here, this is we have the same base, so we can just do the addition, and it's going to be 19 plus negative 23. So this is going to be 10 to the negative fourth. So we have to rewrite it as like this to end up with a positive exponent. For this one here, negative 9 plus 17, that's just going to be, because we have the same base, it's just going to be 4 to the 8th power. For this one here, we have to add the exponents again because they have the same base, negative 4 plus negative 7. So that's going to be 7 to the negative 11th power. And then we have to flip that around like that. And for here, it's going to be x to the negative third times x to the negative 1. So that's going to be x to the same base, so we can add them together. And so it's just going to be right like that. So in terms of simplifying, same sort of idea here. These are subtraction problems in terms of the powers. And so this, if we were to rewrite it out, it would be 5x, and then we do 12 minus 14. So that's going to be negative 2. So we have to rewrite that as 5 on top, and then x to the second power on bottom. This one here, we got x to the negative 12th divided by x to the 19th. So it's going to be x to the negative 12. So negative 12 minus 19 is going to be equal to negative 31. That's a pretty big power. So negative 31. So it's going to be x. Let me rewrite it over here. 31st. Over here, if we have to write it in a positive power way. So here, x to the 15th. So that's 15. Minus, again, since it's subtraction, it's going to be minus, or since it's a division problem, the powers, the bases are the same, it's going to be a subtraction problem in terms of the exponents. Minus negative 9. So that's actually going to be x to the 24th. It can just be written like that. For this one here, it's going to be x to the third. So it's going to be 3. And then this is to the negative 9th power on the bottom, so it's going to be minus negative 9. So that's going to be to the 12th, so it's just going to be 5x to the 12th power. So if you were to look, this is another example, just a quick problem here. Well, this is going to be written as 1, 3 to the 4th and 1 over 4 to the 3rd. Let's do the calculation. This is actually going to be 1 over 81. It's going to be 1 over 64. Is it 64? Let me think. Yes, it definitely is. So which one is actually bigger? In this case, this one is actually bigger. So that's how we do these.